Welcome to the video lecture on voltage, current and resistance calculations brought to you by Formation Professional Private Limited. Now for this lecture, I will not be going through the fundamental concepts of voltage, current or resistance. In fact, what I'm going to go through with you are the important calculation concepts that involve all the three electrical entities. So we first look at the basic formula in electricity. The first one, V equals to IR. This is commonly known as the Ohm's law. V is the potential difference, I is the current, and of course R stands for the resistance. And you should also learn Q equals to IT, where Q is the amount of charge, I is current, and T is the time in seconds. Also need to recap on this. For series connections, the effective resistance will be R1 plus R2 plus R3 all the way until you have N resistors connected in series. For parallel connections, the general formula will be 1 over R is equals to 1 over R1 plus 1 over R2 plus 1 over R3 all the way until you have N resistances. Now let's take a look at resistance calculations. Assume now in front of us we have two resistors connected in parallel. Now how do we calculate the parallel resistance? So if we use the traditional formula, so we have 1 over R to be equals to 1 over 2 plus 1 over 1. Okay, so this 2 ohm means this 2, this 1 ohm means the 1 at the bottom. So to get the answer for this will be 1.5, which essentially means 3 over 2 as 1 over R. So to flip over the fractions, total resistance will be 2 over 3 ohm. Alright, so this formula uses the traditional parallel connections resistance formula, and that's how you get the resistance to be 2 over 3. However, the problem with this formula is that there is always a need to flip over the fractions after you have done the additions of the fractions. Now, many students may just conveniently forget about it, alright, and leave the answer as 3 over 2, which is not correct. Now, another of my method of resistance calculations is to use the idea of product over sum. So I write down here, product over sum. Now what's the meaning of product over sum? Product means that you take the two resistance and multiply together. So in this case I have 2 multiplied by 1, and sum means you add the two resistance together, 2 plus 1, and therefore the answer for this will simply be 2 over 3 ohm, which is the same answer as this. Right? So this is another formula if you want to actually look at. One good thing about this formula is that it's simple, and you do away with the need to flip the fractions before you get a final answer. But take note, this formula is only applicable to 2 resistors. You cannot apply to 3, neither can you apply to anything more than that. Now what happens if you have 2 resistors in parallel and they are of the same resistance? Now of course if you use product over sum, you get the same answer. 10 multiplied by 10 over 10 plus 10. Okay, the same method as before. So you get 100 over 20, you get 5. So the answer is 5 ohm. Now there's a simpler method to actually determine the overall resistance of these parallel configurations. Now just remember that whenever you see 2 resistors connected in parallel and they have the same value, the total resistance will simply be equivalent to that of 1 resistor, which is half of one of them. Okay, so you just take 10 divided by 2, you get 5 ohm. So if you have 2 resistors, both of them are 20-20, the total resistance will simply be 10. Now go into some DC circuits calculations. Now for a recap, series connections, same current flowing through, and the combined voltage is the addition of the potential difference across each component. For parallel connections, the same voltage will be for all the branches, and the current will be split among the branches. Now let's take a look at these circuit calculations. Find the voltage reading and current reading of the ammeters and voltmeters. Okay, let's take a look at the overall resistance. Now the overall resistance here, you actually have got the total resistance to be 5 plus 15, you get 20 ohm. Right? So what we need to do now is that we need to determine the total current flowing. Right? Still remember the formula, V equals to IR. Okay, so to get the current, you will simply take the voltage divided by the resistance. So what is the voltage here? The total voltage is 12 volts. The resistance is 20 ohm. Okay, so you have 12 volts divided by 20, and that will leave you as an answer of 0.6 ampere. So this 0.6 ampere will be the reading of the ammeter. Now what is the voltmeter reading? Essentially the voltmeter measures the voltage across the 5 ohm resistors. So the voltage reading will simply be just current multiplied by the resistance, which is 0.6 multiplied by 5. So this will give you 3 volts. So that's the voltage reading. We have the last example here. Find the voltage and current reading. So the very first thing is that we'd like to determine the total resistance. So the total resistance in this case, now you still remember, you look at this, just now what did I say? When you have two resistors of the same value in parallel, the total resistance will just take half of one of them. So the total resistance here, 10 ohm. Okay, and this will be in series with this 10, so the total resistance is 20 ohm. Okay, right? So in this case, you want to calculate the current again, which will be 12 over 20, and you end up with the same answer as 0.6 ampere. And what is the voltage reading? Use the Ohm's law, current multiplied by resistance, so 0.6 multiplied by 10, and we get 6 volts. So that is the voltage reading. This is all for the video lecture on current, voltage and resistance calculations. Thank you for your attention.